Hi, we're going to begin this problem by using long division to simplify the integrand. So we have x squared minus x minus 5 over x plus 2. The degree on the top is 2, the degree on the bottom is 1, the highest part of x being the degree. So as long as the highest part of x on the top is greater than the highest part of x on the bottom, long division is one of the possibilities that we're going to use for integration, and that's what we're going to do here. So if you've forgotten long division, I'm not going to teach you that, but I'll talk through it in this one example. For any other help that you need in long division, you're going to need to see me outside class time or find some other resource that you can use to reteach yourself this technique. So we start off, we're dividing by x plus 2, so that's what goes on the outside. And we're going to divide it into x squared minus x minus 5. So basically every time what you do in long division is you ask yourself, what do I need to multiply the leading term by here to arrive at the leading term here? Okay, that's what we're asking. And x times what gives you x squared? X times x. So put x on top. Okay. Now, we're then going to multiply down. So we're going to multiply x by x plus 2. So x by x is x squared, and we write the answer underneath. So x by x is x squared. X by 2 is plus 2x. Okay. And then what I like to do is I like to change the signs on the bottom line here. So make that minus 2x squared and make that minus 2x. And I'm going to leave the plus visible because I want you to realize and recognize later on that I have changed the sign. When we add these two lines, so x squared minus x squared, they'll cancel out. And we have minus x minus 2x, so add those and you get minus 3x. Now you bring down the next term as well, which is negative 5. Okay, so now we have x is our leading term on the outside. If I can only get this to work. X is our leading term on the outside. Minus 3x is our leading term here. So you ask yourself, what do I need to multiply x by to get minus 3x? And the answer is minus 3. X times minus 3 will give you minus 3x. So we're going to multiply by minus 3, and we show that by putting it on top. So we're going to put the minus 3 up there on top. Okay. Now this time everything out here gets multiplied by what we just put on top, same as we did before. So everything out here gets multiplied by what we've just put on top, which was negative 3. So negative 3 by x is going to give you negative 3x, and negative 3 by positive 2 is going to give you negative 6. Okay. Next step, remember, is the change of sign. So we change the sign on the bottom line. So this becomes plus 3x, and this becomes plus 6. Okay, and then we add those two lines. So let's add those two lines here now, and you get minus 3x plus 3x. They'll cancel. Minus 3x and plus 3x cancel. Negative 5 and plus 6, that gives you plus 1. Okay. Well, now you've reached the stage where there is nothing that you can multiply x by to get 1. I guess you can multiply by 1 over x, but we're not going there, okay? We're not going to do that. So if you ask yourself, x, another way of saying it is x does not go into 1. Okay, x will not divide into 1. So that means this is a remainder. Okay, so this is a remainder. Okay. And therefore, we now have our answer to the long division part of this. Okay, so we now have an answer to the long division part of it. And that answer is that x squared minus x minus 5 divided by x plus 2 is equal to this thing on top. So you take the thing on top, x minus 3, and then you look at the remainder, which is plus 1, and you put that over the original denominator. Okay, so the remainder goes over the original denominator. Okay, so that's the first part of this work done. So that's the long division done. So make sure you can do the long division. Okay, now our question was to integrate this. Okay, so let's do that. Let's do that now. We want to integrate it, and we want to integrate it between 1 and 2. Okay, so if we want to integrate this between 1 and 2, let's see how we would do that. So the integral from 1 to 2 of x squared minus x minus 5 over x plus 2 dx is going to be equal to the integral from 1 to 2. So if you integrate one side, you have to integrate the other side of x minus 3 plus 1 over x plus 2 dx. Okay. Well, let's integrate this piece, because this is much easier to integrate. Remember, you can't do the integral of this piece directly, because there is no quotient rule. You can't just simply integrate the top and integrate the bottom either. That doesn't work. So you can't integrate the top and integrate the bottom. You can't use a quotient rule. In fact, this is the easiest way to do this problem. So now integrate term by term. So if you integrate x, you get x squared over 2. If you integrate minus 3, you get negative 3x. And now here we see the reason why we did the earlier work in this section. 1 over x plus 2. It's a reciprocal. Okay. And it's going to be a natural log. It's a 1 on the outside and a 1 in front of the x. So I guess if we were being very deliberate, we could say we had a 1 on top, so put that 1 there. And the coefficient of x was 1, so you can put a 1 there. Okay, and there's actually no need for this, because 1 over 1 is just 1. It will go away, but for the sake of explaining the problem in its entirety, let's write it like that for the time being. And then we have the natural log of whatever is under, whatever's in the denominator. Okay, so that's what it looks like. Now it's going to be, the whole thing is going to be from 1 to 2. Okay, so let's now start filling this in. So it's going to be, let's put in the top limit. Okay, if we put in the top limit, we're going to get 2 squared over 2 minus 3 times 2 plus, let's drop the 1 now, plus the log of 2 plus 2. Okay, so that's the first part of it. And now we're going to subtract what happens when we put in the bottom limit. So that'll be 1 squared over 2 minus 3 times 1 plus the log of 1 plus 2. Okay. Well, 2 squared over 4. 2 squared over 2 is 4 over 2, which is just 2 minus 6 plus the log of the absolute value of 4. Well, the absolute value of 4 is just 4, so we can drop the absolute value signs. So that's the first bracket. And then here we're going to have 1 squared over 2 is, oops, let's go back. Okay, 1 over 2 minus 3 plus the log, the absolute value of 1 plus 2 is 3. So no need for the absolute value terms again there. Okay, and now we can tidy this up a little bit. 2 minus 6 is negative 4 plus the log of 4 minus 1/2 plus 3. If you distribute the minus sign, you get negative 1/2 plus 3. 3 minus 1/2 is 2.5, so that's plus 2.5. And then we're going to get minus the log of 3. Okay, well let's see if we can tidy this up a little bit more. Negative 4 plus 2.5, that's going to be negative 1.5. And then plus log 4 minus log 3. Let's keep those two pieces together. We're going to go a little bit further. So that's going to be negative 1.5 and then plus. Now if we look at this, you may have forgotten this, but if we look at this, I can just get my pens to work for me. One of the rules about logs is if you subtract two logs with the same base, you can write them as the log of the first one over the second one. Okay, so there's our answer. Negative 1.5 plus the log of 4 over 3. Okay, and that's it. Now you can verify that by estimating it on a calculator and then go back and do the original integration on a calculator, and it'll show you get the same answer. Okay, that was a long problem. Thanks for sticking through it. Okay.